Hello everybody and welcome back to another Algebra 1 video. Today we will be continuing Chapter 9 with Lesson 9.3 on solving quadratic equations by completing the square. Chapter 9 has focused on how to solve quadratic equations using all kinds of methods. So far we've learned two, the first being graphing and the other one being using square roots. For today we will be learning a third one called completing the square. Before we get into the actual lesson, I wanted to do a brief introduction problem to show you what the purpose of completing the square is. So we're going to solve this equation using square roots. We have x squared plus 6x plus 9 equals 49. So the first thing I want to do is I want to factor this trinomial right here. So what I'm trying to think of are two numbers that multiply to positive 9. And also the same two numbers that will add to positive 6. And so factors of 9, we would have 3 times 3. We know that 3 times 3 will equal to 9, and it also adds to 6. So you can factor this out as x plus 3 and x plus 3 equals 49. And actually, since these are both x plus 3, this just means x plus 3 squared equals to 49. And this looks like a standard quadratic equation that we can solve using square roots. The way we would do that is we're going to square root both sides because we're trying to isolate x and we want to get rid of this squared right here. So squaring x plus 3 squared would just give you x plus 3, and then square root of 49 is plus or minus 7. Then you want to subtract 3 from both sides to isolate x, and you would get negative 3 plus or minus 7. And then you can just go ahead and simplify this using two different equations, so negative 3 plus 7, and then just negative 3 minus 7. Negative 3 plus 7 would just be positive 4, and negative 3 minus 7 would be negative 10. And there are your two answers, or solutions, for x. And so if you noticed anything about this problem, this trinomial right here was able to simplify into x plus 3 squared. And what this is called is a perfect square trinomial. So a perfect trinomial is actually a square of a binomial, and you'll see that right here, x squared plus 6x plus 9 simplified into x plus 3 squared, and x plus 3 would be your binomial. It follows this pattern when it is factored, so that the first and last terms are perfect squares of monomials, and the middle term is twice their product. So what this means is if you take the square root of the first term of a perfect square trinomial, this would be x, square root of this would be 3, the product of this would be 3x, and then if you were to double it, by multiplying it by 2, you would get 6x, and there is your 6x for your second term. So this perfect square trinomial does indeed follow that pattern. You don't need to identify it in the problems that you are doing, but I just wanted to show you this because in today's lesson, we're going to be encountering problems that aren't perfect square trinomials, and we're going to have to make them into perfect square trinomials through using a method called completing the square. So let's go ahead and take a look at our key idea. Another method for solving quadratic equations is called completing the square. In this method, a constant c is added to the expression x squared plus bx, so that x squared plus bx plus c is a perfect square trinomial. To complete the steps for an expression of the form x squared plus bx, follow these steps. Step 1, you're going to find 1/2 of b, the coefficient of x. Step 2, you're going to square the result from step 1. And then step 3, you're going to add the result from step 2 to x squared plus bx, then factor the resulting expression as the square of a binomial. All of these steps will make sense once we go into a practice problem, but I want to make sure that you note down this formula, b over 2 squared. This is what you're going to need to find your constant c in order to solve using completing the square. So let's go ahead and look at our very first example. We're going to complete the square for this expression, then factor the trinomial. We have x squared plus 6x. Step 1, what I want to do is find 1/2 of b and square it. So this is in the format ax squared plus bx. In this case, our b value would be positive 6. Make sure you're paying attention to the sign that is in front of the value. And so now that we found our b value, we can go ahead and plug it into this formula of b over 2 squared. Just substitute b with 6, and then 6 over 2 would just be 3. So this is just 3 squared, and 3 squared would equal 9. Now that you found your c value, which is just 9, you can add it to your binomial expression, in this case x squared plus 6x. If you add 9, it would make it x squared plus 6x plus 9, and all you have to do now is factor it. So I'm looking for two numbers that will multiply to positive 9, and those same two numbers should also add to positive 6. Factors of 9 would be 3 times 3. Those multiply to 9, and they also happen to add to 6. So this would be x plus 3 times x plus 3. Alternatively, you can just express it as x plus 3 squared. Also, there is a quick trick to factoring when it comes to completing the square. Rather than factoring everything out, you can simply just take half of your b value. In this case, it would be 6 divided by 2. And since your entire trinomial is positive, it would just be x plus 3 and then squared. So just take the number that you add or subtract from x in factored form is just half of b. And this will be especially helpful when we get into problems that have fractions. For example 2, we're going to complete the square for this expression, then factor it. So you have x squared minus 9x. First thing I want to do is find 1/2 of b and square it. So I'm using the formula b over 2 squared. First, identify your b value. It's going to be negative 9. Again, make sure you pay attention to the signs in front of your values. So I would just substitute negative 9 for b. This would be negative 9 over 2 squared. And whenever you have a fraction like this, since negative 9 can't be divided by 2, you can just do it individually, where you have negative 9 squared over 2 squared. This would give you 81 over 4. And now that you found your c value, which again is 81 over 4, you just have to add it to your binomial expression. So it'd be x squared minus 9x plus 81 over 4. And now all you have to do is factor the trinomial. Looking at your c value, it is a fraction, and it's definitely a little bit more complicated to factor out fractions. So I'm going to use that tip that I gave in the previous slide. So the number that you add or subtract from x in factored form is just half of b. So in this case, b was negative 9, so it's just negative 9 over 2. And your factored form would just be x minus 9 over 2, and then squared. And there's your final factored expression. And if you were to FOIL this out, you would see that it does indeed equal to this trinomial right here. And there is your final answer. For example 3, we're going to do another similar problem. We have x squared plus 10x. First thing I want to do is find 1/2 of b and square it. Our b value in this case would be positive 10. So I would substitute b for 10. That would give you 10 over 2 squared. 10 over 2 is just 5. And 5 squared would equal to 25. 25 would be your c value. So now you can just add it to your binomial here. That'd be x squared plus 10x plus 25. And so we can now factor this out. Two numbers that would multiply to positive 25 and two numbers that would add to 10. That would be 5 times 5 and 5 plus 5. And so this would just be x plus 5 squared. Alternatively, again, you can just follow this format of x plus a value squared. And to factor it, you would just have to find half of b. In this case, it was just positive 5. And then you can go ahead and plug it in there. And you would get your factored expression. Here is example 4. Now this problem looks a little bit different. We're going to solve x squared plus 8x minus 3 equals 17 by completing the square. Now the reason why this problem looks different is because we're not given a binomial expression this time. We're actually given a full trinomial and it is an equation. But we're still going to follow the same exact thought process with just a few additional steps. The first thing you want to do is you actually want to isolate this binomial right here and cancel out this c value so that you can replace it with your b over 2 squared value. So the way you would do that is you would just add 3 to both sides, and that would get rid of this minus 3 right here. So that would give you x squared plus 8x equals to 20. Now if you look at the left side of this equation, you see that we have that binomial that we've been working with in all our previous problems. So now we can find our c value using the b over 2 squared formula. So in this case, our b value would be positive 8. And so I would just substitute b with 8, and this would be 8 over 2 squared. 8 over 2 would just be 4 squared, and then 4 squared is 16. So your c value equals to 16. Now you're going to do the same exact thing where you add your c value to your binomial, except this time, since it is an equation, you're actually going to have to add 16 to both sides of the equation to balance it out. So you're going to add 16 to x squared plus 8x, and you're also going to add 16 to 20. So this is how it would look like. And then you can go ahead and simplify 20 plus 16. That would just be 36. So you would have x squared plus 8x plus 16 equals to 36. And now you want to factor your trinomial right here, x squared plus 8x plus 16. The way you would do that is that you want to find two numbers that multiply to positive 16, two numbers that add to positive 8, and they should both be the same number. So 4 times 4 equals 16, and 4 plus 4 equals to 8. Again, if you wanted to take the shortcut, you can just take half of b. In this case, it would be positive 4, and then plug it into the x plus a value squared format. So your trinomial would be simplified to x plus 4 squared equals to 36. And since this is an equation, we're going to have to solve for x. So this looks like a standard equation that we would solve using square roots. So I'm going to square root both sides to get rid of this squared right here. That would leave you with x plus 4 equals 2 plus or minus 6. Now that you have negative 4 plus or minus 6, you can just go ahead and simplify this. So you would have either negative 4 plus 6, which would equal to positive 2, or negative 4 minus 6, and that would equal to negative 10. And those would be your two solutions for x. Here is example 5. We're going to solve x squared plus 12x plus 3 equals 1 by completing the square. Again, we have a full trinomial and it is in equation form. So the first thing I want to do is get rid of c, and I'm going to do that by subtracting 3 from both sides. If you subtract 3 from both sides, 3 is going to cancel, and 1 minus 3 is just negative 2, so now you have x squared plus 12x equals to negative 2. And now you can find your c value by having your b value, in this case 12, and then squaring it. So b over 2 squared would just be 12 over 2 squared. 12 over 2 is 6, then 6 squared would equal to 36, and 36 would be your c value. So now you can add it to this binomial right here, x squared plus 12x, but remember again that it is an equation, so you have to add 36 to both sides to balance it out. So you would have x squared plus 12x plus 36 equals to negative 2 plus 36. And now you can simplify negative 2 plus 36. This would just be positive 34. And you can also factor this out. So this would be x plus 6 squared, since half of b would just be 6. And then I'm following the format of x plus a value squared. And that would be your factored form. So your simplified equation would be x plus 6 squared equals 34. This again looks like the standard equation we would solve using square roots. So I'm going to go ahead and square root both sides. If I square root x plus 6 squared, I'm going to get rid of the squared, and this would just be x plus 6. And then square root 34 does not simplify, so it would just be plus or minus square root 34. And to finally isolate x, I would just subtract 6 from both sides, and your final answer would be x equals to negative 6 plus or minus square root 34. And since you can't simplify square root 34 any further, it's fine to leave your answer like this. Here is example 6. We're going to solve 2x squared plus 4x plus 10 equals 58 by completing the square. But one important thing to note is that to complete the square, the leading coefficient must be 1. As in all our previous problems, completing the square worked because we only had x squared. But in this case, our leading coefficient is 2. So the very first thing I want to do is divide everything, both sides of the equation, by 2. And since it is an equation, you can divide both sides. So 2x squared plus 4x plus 10 equals 58. I'm going to divide 2x squared by 2. I'm also going to divide 4x by 2, 10 by 2, and 58 by 2. This would simplify to x squared plus 2x plus 5 equals to 29. And now that we have a leading coefficient of 1, we can go ahead and carry on with the complete the square process. First, I want to get rid of my c value right here. So I'm going to subtract both sides by 5. That would give me x squared plus 2x equals 24. And now I can add my c value. Again, the formula for your c value is b over 2 squared. In this case, our b value is positive 2. So 2 over 2 would just be 1. Then 1 squared would just be 1. And so you can go ahead and add that to your binomial expression and also to both sides of the equation. So you would have x squared plus 2x plus 1 equals 24 plus 1. I'm going to go ahead and simplify 24 plus 1 to just 25. As for x squared plus 2x plus 1, it would just be x plus 1. Again, I'm using the shortcut where you find half of your b value, so just divide your b value by 2, and that's the value that you're either going to add or subtract to x squared. Since your b value is positive, this would just be x plus 1 squared equals 225, and this we can solve using square roots by taking the square root of both sides. This would give you x plus 1, the square root would cancel out your squared here, and then plus or minus 5. And now to isolate x, you would just subtract both sides by 1. This would give you x equals to negative 1 plus or minus 5. Now all you have to do is evaluate both solutions, so negative 1 plus 5 would equal to 4, and negative 1 minus 5 would equal to negative 6. So your two solutions for x are positive 4 and negative 6. Now we have a real-life application problem. You throw a stone from a height of 16 feet with an upward velocity of 32 feet per second. The function h equals negative 16t squared plus 32t plus 16 gives the height h of the stone after t seconds. When does the stone land in the water? So first, let's go ahead and write down the equation that we are given. We're trying to find when the stone lands in the water. So we're trying to solve for our variable t. Also, I'm going to set my equation to 0 because in this case, when the stone lands in the water, h or the height is going to be 0 feet. So you can just set it to 0. And now we have negative 16t squared plus 32t plus 16 equals 0. We can solve this using complete the square. But looking at our leading coefficient, we have negative 16. And we need our leading coefficient to be 1. So I'm going to divide everything by negative 16. So if you do that, negative 16t squared turns to just t squared. 32 divided by negative 16 would give you negative 2t, and then positive 16 divided by negative 16 would be minus 1, and then 0 divided by negative 16 would still be 0. So now you have an equation that you can use complete the square to solve. So you have t squared minus 2t minus 1 equals 0. First, I want to get rid of this minus 1 right here so that I can replace it with my c value. I'm just going to do that by adding 1 to both sides. That would give you t squared minus 2t equals 1. And now you can find your c value by taking the half of your b value, in this case negative 2, and then squaring it. So it would be b over 2 squared. Your b value again is negative 2, so you would have negative 2 divided by 2 squared. That would just be negative 1 squared, which would just equal to positive 1. And now you can add it to both sides of your equation. You would have t squared minus 2t plus 1 equals to 1 plus 1. So now I'm going to factor out my trinomial. In this case, it's going to be t, and then trying to find what I either add or subtract. In this case, we have negative 2 divided by 2, and that would just equal to negative 1. So I'm going to subtract 1, and your trinomial would just be t minus 1 squared, and then 1 plus 1 just equals to 2. Now you have an equation that you can use square roots to solve. So I'm going to take the square root of both sides. That would cancel out this squared right here. And that would give you t minus 1 equals 2 plus or minus square root 2. Square root 2 can't be simplified, so you can just leave it as is. Now add 1 to both sides. and that would give you t equals to 1 plus or minus square root 2. Now, if you were to plug in both 1 plus square root 2 and 1 minus square root 2, you would get two different values, one being negative and one being positive. It's not possible to have a negative number of seconds, so make sure you're choosing the positive value. And if you plug in 1 plus square root 2, you'll get approximately 2.4 seconds. That is it for today's lesson. Thank you so much for watching. If you have any questions about what I cover in these lessons, please feel free to email me at kaylin.david24@gmail.com. I'm always active on my email, so I'll be sure to respond. As always, all information regarding tutoring, additional practice, and lesson requests will be linked down below. Thank you again for watching, and I hope to see you in the next lesson.